Hello everyone. So in this video of acids, bases and salts, I'll be talking about what do all acids and all bases have a common thing, and some chemical properties of bases and pH scale. All the acids contain hydrogen. For example, HCl, H2SO4, CH3COOH, H2CO3, all the acids which we are calling these are acids contain hydrogen atom. And some of them one hydrogen atom, some of them more than one hydrogen atom. The hydrogen atom present in acids is such that when an acid is dissolved in water, it will produce hydrogen in the form of hydrogen ion in the solution. And because of the presence of hydrogen ion in the solution, we call a solution as acidic. Or I can say here, an acid is a substance which ionizes on dissolving in water to produce hydrogen ions. For example, HCl, if I am diluting it, if I am dissolving in water, it will give me hydrogen ion and chloride ion. It is the presence of hydrogen ion only in HCl solution which makes it behave like an acid. And now this hydrogen ion does not exist as hydrogen ion in a solution. It used to attach itself with water molecule to give you hydronium ion, H3O positive charge. So I can say here there is one common thing in all the acid, whether it is a weak acid or the strong acid. The one common thing is the producing hydrogen ion in aqueous solution, and that hydrogen ion will going to combine with water molecule to give you hydronium ion. Now we are going to talk about what are the bases and what is the common thing in the base. Base are the substances which used to produce hydroxyl ions or OH ions in aqueous solution. Base like NaOH, KOH, they used to exist in a solid state. And when these solids are dissolving in water and they are very much soluble also, the solution which are generally formed is called as alkali. For example, when solid NaOH or KOH is dissolving in water, it will give you sodium ion or potassium ion respectively, plus hydroxyl ions also. There are other bases like calcium hydroxide, magnesium hydroxide, ammonium hydroxide, and one thing which we are seeing here, the common thing is the hydroxyl ion in any molecule. On dilution, on in aqueous solution, all the bases, if we are calling it is a base, will give us hydroxyl ion. Bases are also of two types: strong base, weak base. Strong base are those which used to give you large number of hydroxyl ion in aqueous solution, or they used to ionize completely. All the molecule will ionize and give you hydroxyl ion which are very large in number. And for example of the strong base are KOH and NaOH. Weak base, where all the molecule will not ionize to give you large number of hydroxyl ion, they will produce less number of hydroxyl ion on ionization. For example, calcium hydroxide, magnesium hydroxide and ammonium hydroxide. Now some reaction of base. Reaction number one is when any alkali like NaOH is treated with metal like zinc, it will give you one metal salt which is called as sodium zincate plus hydrogen gas. And one base like calcium hydroxide is reacting with non-metallic oxide like carbon dioxide, it will give you calcium carbonate and water. It is also a confirmatory test of carbon dioxide, I told you earlier. Now, how strong are acid or base solution, or how would we determine the strength of an acid or basic solution? And we used to determine the strength of an acid or basic solution in terms of pH scale. Earlier we have learned acid base indicators. they used to distinguish between acid and base. And we have also learned about the strong acid and weak acid, or strong base or weak base, on the basis of large amount or small amount of hydrogen ion or hydroxyl ions in the solutions. Now we are going to learn how hydrogen ion concentration vary in an solution. Before that, I want to tell you, we have also heard about universal indicator. Universal indicator is a mixture of several indicators. The universal indicator shows different color at different concentration of hydrogen in a solution. And to measure the different concentration of hydrogen ion in a solution, one scale is devised which is known as pH scale. Before that, I want to put up one question right here. For example, I have one acid HCl and I have one base NaOH. And the question is, do the basic solution, that is NaOH solution, also contain hydrogen ion? If yes, then why they are basic? And the question number 2 is, do hydrochloric acid solution, does it contain any hydroxyl ion? If it is there, if hydroxyl ions are there, then why they are acidic? The answer is yes, because NaOH is dissolving in water, and to give large amount of hydroxyl ions, some amount of hydroxyl ions are coming from water molecule also. At the same time, water is also providing hydrogen ion in a small amount, but they are there. In this case, what is happening? The hydroxyl ion concentration is so large than the concentration of hydrogen ion. That is why they are basic. Whereas in case of acids, acids are dissolving in water to give hydrogen ion, but hydroxyl ions are also coming from water, but the concentration of hydroxyl ions are quite low than the concentration of hydrogen ion present in the solution. That is why they are acidic. To measure the hydrogen ion concentration in a solution, one scale is developed which is called as pH scale. P means potence. It is a German word and it means power. And hydrogen is hydrogen. On the pH scale, we can measure the concentration of hydrogen, and this scale is started from 0 to 14. pH of the solution is giving us the idea of the nature of the solution. The midpoint of pH scale is 7. If I am telling you this solution is having pH value 7, that means the concentration of hydrogen ion and the concentration of hydroxyl ion in this case is exactly equal. That means the solution is neutral. And at extreme left, the pH value is 0. That means it is highly acidic. The hydrogen ion concentration is very high in that case. If I am saying the pH of solution is 14, that means the hydrogen ion concentration in this case of solution is very low, or the hydroxyl ion concentration is very high in this case and it is basic in nature. Now, I can say here, on moving left to right on pH scale from 0 to 14, the concentration of hydrogen ion will keep on decreasing and the concentration of hydroxyl ion will keep on increasing. I can say here, from pH value 0 to 6.9 will be having acidic solutions. From pH value 7.1 to 14 we will be having basic solutions. And If I am moving from pH value 7 to 0, that means there is an increasing in the hydrogen ion concentration in the solution, or there is a decrement in hydroxyl ion concentration in the solution. If I am moving from pH value 7.1 to 14 on pH scale, that means there is an increment in hydroxyl ion concentration or decrement in hydrogen ion concentration. And if you have pH value from 0 to 3.5, you are having quite strong acids. If you are having pH value from 10.5 to 14, you are having strong alkalis or strong basic solutions. And at the extreme, from pH value like 13, 13.5, 14, if you are having such pH value, that means the basic solution which you are taking are the strong basic solution. They are made up of strong base. And if you have pH value 0 or 0.5 or 1, that means you are having extremely strong acids. So this is all about the pH scale.